Right. Hello, faculty and fellow students. We are Team Soundbyte, and this is our vlog number 6. My name is Brandon Clark, and I'm working with Mason Lane and Brian Jiwon Kim. So, as a quick overview of what we're doing, Soundbyte aims to organize a user's music library in a fresh light to provoke new creative ideas. We suggest songs that might make for a good music sample, mix, mashup, or fade out. A quick overview of all of the roles and responsibilities of each of our group members. Myself have been primarily responsible for machine learning and suggestion component of the application, the science, research, and development behind that. Brian Jiwon Kim has been responsible for the front-end design and development, in addition to some back-end development, and Mason Lane has acted as our Scrum Master, as well as been responsible for the back-end and front-end architecture, as well as the back-end development and feature extraction. So to start, we'll talk about where it all started with gathering requirements for our application. We began with some empathy mapping to get an idea for our project scope and the general need present for our application. Of course, this was followed up by more thorough affinity diagramming and user stories. This established epics, which would be later used in the creation of our storyboard. So for this process, we tried to get our boots dirty and on the ground and really interview the users that we had in mind for this application. So we spoke to musicians, DJs, creators, and hobbyists. After our storyboard and epics were established for our application, we moved on to creating our technical implementation. Our initial design planned for Amazon Web Services, but as we experimented and discovered that it was not viable, storage of songs and request times would bring us over budget. Machine learning options, earlier we explored building our own model using TensorFlow, and also an early exploration of a library called Essentia. Though we did not initially adopt it, we still kept it on the back burner as a possibility, which we'll speak about a little bit more later. Next, Brian will talk about the UI design a little bit.
Thank you. In speaking to the UI design, our lo-fi design more focuses on web application stack, such as responsive and progressive pattern. However, after we decide to use Electron as our front-end stack, we don't need to consider the pattern anymore. So the hi-fi design have had fixed design components using JavaScript, native JavaScript, and document object model, and TypeScript, CSS, and HTML.
And of course, we also began work on our architecture for the application. We began with use case diagrams, as well as our model view controller pattern, and then from there derived class model, data dictionary, and activity diagrams, which can be easily found on our GitHub page.
Speaking to front-end development, we call a library data object from JSON, which is generated by our middleware and backend. And then input may be sent through the selection of various checkboxes, which is sent either a song or feature object. This is sent to the backend to process the results. They may also select a random input. And then once the results suggestion generated as JSON, it gets presented on the screen by using DOM and JavaScript. After that, users are allowed to filter their library and results and have limited input options to avoid errors. The final functions is users can play each song by pushing the play button they want.
And of course, we also did work on our middleware, where we established our various types, which maintained faithfulness to our architecture. Uh, Generic types would extend into other types with greater meaning and purpose, such as the suggestion interface. And of course, we handled here the majority of data, which passed between the backend and the front end. TypeScript was a good choice for maintaining the object-oriented direction we were trying to go. And of course, we call elements of our Python backend from a Python shell, which we'll get into later. So to the right, you'll see examples of both the song and suggestion objects, two different types. And working towards our backend, we of course did end up using Essentia JavaScript, which is not the same as Essentia, which itself is a C++ library that has Python bindings for Linux. Our initial attempts would be to use it in Python, but it was easier to use Essentia.js. Essentia did not work well as a node module initially, being a Chromium application. Here, WebAssembly files may not exceed 4 kilobytes, and while Electron is for desktop applications, it's technically such a web app. So to resolve this issue, we used web workers or multi-threading, and we're able to thereby fix the issue. Ultimately, we read tag metadata, measure song length, and decode an audio stream. After doing so, we extract the important features using Essentia.js within the web worker. Now on to loading times. I believe we will discuss it in further detail after our demo.
All right, now moving into the suggestion portion of the backend. The way that this works is, as Mason spoke to, we have a Python shell from TypeScript that we run a Python script to evaluate and give similarity values to each of the songs in the user's library based on whatever the input was. So the input to the Python script is going to be the user's entire song library plus one of a song object, a feature object, or a random song object. And this will be seen a little bit later in our demo. So the output of the Python shell returned back to the TypeScript middleware is going to be a weighted sum of the differences in features. So this will be the difference in BPM and also the difference of notes in each key and scale. So as you can see on the image on the right there, we have an input going in with BPM 35, key B minor, and we have an output array of ordered users library. So next, I'll speak quickly about some other design changes that we've made in the process of developing this application. So originally we set to do all our backend in Python, so this would be our feature extraction as well as our suggestion. We originally planned to do this using an LSTM, which is long short-term memory model. To train this model, we originally had planned to use the Million Songs dataset. The Million Songs dataset helped to shape what was possible and what we hoped to achieve. It included over 40 features for most songs, making the possibilities endless. Unfortunately, the dataset is nearing 10 years old and all of the distribution links were broken. This, in combination with the lack of music in our libraries to train on, brought us to a screeching halt. As Mason touched on earlier, we had Essentia kind of on the back burner as one of the options that we could take for feature extraction, but we wanted to explore a home-built model first. After, like I said, us coming to a screeching halt, we decided that we needed to implement Essentia.js and started going down that path. I spoke to this a little bit earlier, but originally we had planned for an architecture on Amazon Web Services, such to make this an application that was a web app, so that it would be very easy to use on any platform. As I kind of spoke to earlier, we quickly realized the logistics of uploading an entire user's library was not feasible and incurred some legal concerns regarding the rights of the songs that were being uploaded. And this prompted the change for a desktop app, which was probably the biggest change in our entire development process. So now speaking to the documents that kind of wrapped up our process, which is the code review and the after action report, just to kind of touch on a few of the main ideas that we as a group got out of those. So the code has standard naming conventions and highly readable. Determining the function of a block of code with fresh eyes is an easy task due to the use of these standard naming conventions. And the code does not extend off the edge of the screen on a small laptop, so it does not overwhelm the user, or the viewer rather. We tried to keep in mind standard software engineering principles, so throughout development we try to take an object-oriented approach to our application. As we spoke to a little bit earlier, the types really helped us in this. So every block of code has a defined responsibility and a standard set of inputs such that it is easy to swap and rearrange blocks of code as necessary. One downfall that we encountered during our code review is that our code lacks formal automated testing, but we did perform manual testing as well as user testing to ensure some functionality in our application. Another downfall, which is probably one of the largest, is currently the amount of songs that can be loaded at once is a bit of a burden. The application at around 2,000 concurrent songs trying to extract features will crash. We've determined that the solution for this would be to implement a queue or some sort of processing on the fly of songs in a user's library. Finally, our after action report revealed that we feel very good about the usability and functionality of our application. Our app suggests songs with parameters that can be varied by the user, and this process is very, very intuitive. We feel as if the main area for improvement is the performance of the feature extraction that I just spoke to.
Thank you, Brandon. And I believe we'll quickly show off the poster, because of course we are doing that during our sprint as well. So that is our completed poster. I'm excited for everyone to see that. And of course we'll quickly show off our commercial.
Are you a DJ, or perhaps you mix music as a hobby? Whatever your creative reason, you've probably kept an extensive list of songs at one time or another. Sure, you could organize a library, but that would mean intimate knowledge of each song. Somewhere in there are likely 2 songs you've never considered, a potential mix never realized. What's more, there's no saying you'll recall a candidate. Sometimes a person needs a little inspiration. Enter Soundbyte, which aims to suggest music that might pair nicely. From your library of songs, you can easily narrow down a digestible number of options, all with a similarity percentage for your convenience. Got a song you want to work with but no idea what to match? Use our application and we can get you started. Our application eliminates unlikely candidates while maintaining much of your creative license. In the end, the choice is yours. We simply curate. Using our application is simple. After an initial setup period, you'll have instant access to your library. Suggestions are expedient and the handiness persists even after relaunching the application. With your library prepared, we've included a variety of input options for your convenience. Select a song and send it for analysis. We'll suggest its nearest candidates. Perhaps you'd like to play a game of chance. Choose one at random and see where the inspiration takes you. Or maybe you have a set of features in mind, but no song. Simply send your features manually and we'll make the suggestion regardless. Professional or hobbyist, whatever your reason, our desktop application pairs excellently with your workflow, suggesting the next track for your mix. Partner up with other professional software and you've got a steady flow of ideas for your Mixcraft project or live performance.
And I believe then this now brings us to our demo, which will be a brief live demo. You've seen much of it in the commercial, but of course users can enter suggestions through custom input of features. And we can see that here the similarity is very poor. They can select the length, or they can select a specific song and see what the result is. And of course, rock and roll ain't noise pollution is much more alike with Back in Black. So I will quickly reset the library, change the library to another set of songs, just so that we can show kind of our load time issue that we've discussed. And here it is preparing data, and you'll see that the load time takes a little too long. So while it's doing that, I will show you some plans beyond our MVP that we have planned, or aimed at. So one of the reasons why we cut certain features and are avoiding doing them is because we could actually improve the application a lot more before including those features, and it would benefit by doing it in that order. So currently, because we load our songs asynchronously, it holds up the DOM for too long, and the user, it's not like a good experience for the user. So since we have web workers and multi-threading, what we can do instead is run every extraction synchronously and slowly propagate the library for the user with the valuable features. Of course, we could easily extract the name and features such as that, which aren't as difficult to extract, but the important ones we would do slowly and over time, so that the user may still interact with the interface and request suggestions for songs that have been loaded. So by doing this order, or by redesigning it like this, it would enable us to create a more object-oriented application, and also include features such as like individual addition of songs, updating songs, deleting songs, and better error handling when we trip up on one song instead of having to restart the process. And of course, now that it's loaded, you'll see that we have 2 songs. So here's our GitHub. It is up to date, and this is a quick glance at our roadmap. We got a lot of our stuff done. The pieces of our development that are not finished are mainly the iterative pieces, so we want to practice more with our suggestions to create better models, and we also would like to save results, which we haven't been able to finish quite yet. I believe that concludes our vlog 6 for this week, and we're very excited to see everyone in presentation day. Thank you for watching. Bye-bye.